Darkness falls, but not the kind we know. Compasses spin wildly, satellites lose their sense of direction. Across the planet, invisible shields begin to crack. Something ancient, something buried deep within the earth, has suddenly reversed. North is no longer north. South is no longer south. In a single moment, the planet's magnetic heart flips, and humanity is left exposed. This is not science fiction. Magnetic pole reversals have happened before, but never like this. Not overnight, not in a world so dependent on fragile systems. So what would really happen if Earth's poles flipped in a single day? To understand the danger, we need to understand what's actually flipping. This is not the geographic poles. The North Pole and South Pole would stay exactly where they are. What changes is the magnetic field. Deep beneath our feet, around 3,000 kilometers below the surface, lies the outer core, a swirling ocean of molten iron and nickel. This liquid metal moves constantly, driven by heat escaping from Earth's inner core. That movement generates electricity. And that electricity creates a vast magnetic field, stretching far into space. This field surrounds our planet like a protective bubble. It deflects deadly solar radiation. It shields our atmosphere from being stripped away. It makes life possible. And it gives us something we take for granted every day: direction. But what if, suddenly, that entire system reversed? What if magnetic north became magnetic south? Instantly, the magnetic field is not just a tool for navigation. It is a shield, a barrier between Earth and the violent forces of the sun. Without it, Earth would be exposed to a constant stream of charged particles, solar wind traveling at millions of kilometers per hour. Normally, these particles are deflected. They flow around the planet, guided by magnetic lines stretching from pole to pole. Some particles slip through near the poles, creating auroras, beautiful lights dancing across the sky. But if the field weakens, if it collapses, those particles don't just paint the sky. They strike the atmosphere directly. They penetrate deeper. They interfere with electronics. They damage biological tissue. And they begin to reshape the environment itself. A magnetic reversal doesn't mean the field disappears forever, but during the transition, it weakens. And if that transition happens overnight, there is no time to adapt. Magnetic reversals are not new. They have occurred hundreds of times throughout Earth's history. The last major reversal happened around 780,000 years ago, known as the Brunhes-Matuyama reversal. But here's the critical difference. It didn't happen overnight. It took thousands of years. The magnetic field slowly weakened, became unstable, and eventually flipped. During that time, life adapted. The planet adjusted. There was no sudden collapse. No immediate global crisis. Even today, scientists have observed that the magnetic field is slowly weakening. The South Atlantic anomaly, a region where the field is unusually weak, continues to grow. Some researchers believe we may already be in the early stages of a future reversal. But again, this is a slow process. Measured in centuries. Not hours. So what happens if we compress thousands of years into a single day? Our zero. It begins without warning, deep within the core. The flow of molten metal shifts violently. Magnetic lines twist, tangle, and collapse. Within minutes, compasses around the world begin to drift. Navigation systems show errors. Aircraft instruments flicker. Ships lose orientation. At first, it seems like a glitch, a system failure, but then it spreads. The magnetic field weakens dramatically. Its strength drops by more than 80%. Satellites in orbit begin to experience increased radiation exposure. Some shut down automatically, others fail completely. GPS signals become unreliable. Timing systems collapse. Communication networks start to fragment. On Earth, power grids begin to feel the strain. Geomagnetic currents induced by solar particles start flowing through transmission lines. Transformers overheat. Voltage spikes surge across continents. The sky begins to change. Auroras appear far from the poles. Bright, unnatural lights shimmer over cities, deserts, and oceans. They are beautiful, but they are a warning. Solar radiation is reaching deeper into the atmosphere. Airlines ground flights as navigation becomes impossible. Pilots lose reliable positioning. In space, astronauts are exposed to dangerous radiation levels. Emergency protocols are activated. The magnetic field collapses into chaos. Instead of a single, stable dipole, multiple temporary poles appear. Magnetic north could exist in several places at once. then vanish. Then reappear elsewhere. Navigation becomes meaningless. Animals begin to panic. Birds lose their migratory paths. Whales stray off course. Sea turtles swim in the wrong direction. For millions of species, the magnetic field is not optional. It is a guide, a sense. And now, it is gone. Our 12 solar wind slams into Earth's atmosphere with full force. Without a strong magnetic shield, charged particles penetrate deeper. They ionize the upper atmosphere. Radio communication fails across large regions. Military systems lose coordination. Emergency services struggle to respond. Power grids begin to collapse globally. Major cities go dark. Not for minutes, but for days. Our 18 radiation levels increase. At ground level, the atmosphere still provides protection, but at higher altitudes, exposure becomes dangerous. Air travel halts completely. Satellites continue to fail, one by one. Weather forecasting systems go offline. Global positioning is lost. The modern world begins to unravel, not because of destruction, but because of dependence. Heretofore the reversal complete poles have flipped. Magnetic north is now in the south. Magnetic south is now in the north. The field begins to stabilize, but it is weaker than before. The immediate chaos slows, but the consequences are only beginning. In the days that follow, the world struggles to recover. Power grids require massive repairs. Satellites must be replaced. Navigation systems need recalibration. But the deeper effects are harder to fix. Increased radiation exposure damages infrastructure. Electronics fail prematurely. Some regions experience higher cancer risks due to prolonged radiation levels. Animal migration patterns are disrupted for years. Ecosystem shift. Food chains are affected. And then there is the atmosphere. Without strong magnetic protection, solar wind begins to strip away tiny portions of it. Not enough to cause immediate catastrophe, but over time, measurable changes begin. We have seen this before, not on Earth, but on Mars. Mars once had a magnetic field. It once had a thicker atmosphere. Liquid water flowed across its surface. But when its magnetic field weakened and disappeared, solar wind stripped away its atmosphere. The planet became dry. Cold. Lifeless. Earth is not Mars. Our gravity is stronger. Our atmosphere is thicker. But the lesson is clear. Without a magnetic shield, a planet becomes vulnerable. Humanity adapts. It always does. Engineers redesign power grids to withstand geomagnetic storms. Satellites are hardened against radiation. New navigation systems are developed, independent of magnetism, but the transition is costly. Trillions of dollars. Years of disruption. Global coordination on a scale never seen before, and all because of something we cannot see, cannot touch, but depend on every second of every day. The magnetic field is invisible. Silent. Often ignored. But it is one of the most important forces protecting life on Earth. A sudden reversal would not end the world, but it would expose how fragile our systems truly are, how dependent we are on stability, on predictability, on forces we barely understand. The Earth beneath us is not static. It is alive. Dynamic. Unpredictable. And sometimes it reminds us of that. If something as fundamental as Earth's magnetic field can change suddenly, without warning, then what other hidden forces are shaping our future right now? And the next question is even more unsettling. What if the change doesn't come from below, but from above?